two layers we just talked about. The top layer is made of reflective material, kind of like a mirror that bounces back light when we point it at it. The way data is stored is by creating holes in this reflective layer. The method for increasing capacity from 700 megabytes in 1982 to 25 gigabytes today was mainly by making these holes smaller on the same surface. That's why the disks haven't grown a single inch in size over all these years. At the top, we have a laser that points at the disk and a light receiver next to it. When we look at the disk in this plane, we can notice dents and bumps, which we can better understand as valleys and mountains. When the laser hits a valley, the light doesn't reflect at that part of the disk, so the binary value is 0. But when the laser hits a mountain, it encounters the reflective material, causing the light to bounce back to the receiver, and that part of the disk is assigned a binary value of 1. This way, using valleys and mountains, we can represent binary code on the surface of optical disks. But how is it that if Blu-rays can only store 25 gigabytes theoretically, they can store games of 80 gigabytes or movies of that size too? Well, remember that earlier I mentioned that movies or games used to come on disc 1 and disc 2 because one disc wasn't enough. Exactly the same thing was done here, but how does it work? Simple. By adding a layer of data beneath the one we already had. Easy, right? But there's something strange. How can the laser read the data from the lower layer if there's another layer on top? The solution is simply in how light behaves. By changing the focus of the laser, it can pass through the first layer, which was reflecting, and read the data from the layer beneath it. This way, we can stack multiple layers on top of each other to store more and more data. It's just like having disc 1 and disc 2, but in a single disc. Simply fascinating. Well, you're probably asking, how can a laser reflect off a surface and also pass through it to read data underneath? Don't worry, I asked myself the same thing when researching. What happens is that this process relies on the nature of how light behaves, based on the principles of quantum mechanics. Even scientists find this tricky to understand sometimes, but it works, and it works beautifully. Thanks to this, we can now distribute games and movies that are several gigabytes in size on a single disc. Currently, there are no 300 or 500 gigabyte discs, because there's simply no demand for them. There are Blu-ray discs with triple or quadruple layers, with a maximum capacity of around 130 gigabytes. However, dual-layer discs are usually sufficient for most multimedia products. It's also worth mentioning that creating a 6 or 8-layer disc is very difficult. And of course, optical discs are no longer the primary method of distribution for everything like they used to be. The reason why a regular DVD or CD player can't read Blu-rays is that the holes in these discs are smaller. And in order to read them, you need blue or violet light, which has a shorter wavelength suitable for the smaller holes in these discs. That's where the name Blu-ray comes from. An interesting and curious fact is that CDs and DVDs used red or infrared lasers, but Blu-ray technology was delayed for a long time, mainly because creating blue LEDs was a nearly impossible challenge for engineers for decades. Only red LEDs existed, and later green LEDs were created. It wasn't until 1994 that Japanese scientist Shuji Nakamura succeeded in creating the first efficient blue LED. And thanks to this invention, we now see this video on an RGB screen, and our world is as we know it today. But that's a topic for another day. Thank you so much for watching.